Hello. Hi guys. Hi. So today I want to talk about normalization again, but not the future, but the harder forms of it. Before, in the previous videos, I have explained how 1, 2, and 3NF work, which will be normally you'll be using them in any kind of sort of industrial application or any of your projects, most probably. Now these all of here are very niche, are very sometimes rarely used. Till like here you will use it sometimes. These very industrial people or very core people will use or will even get to use actually. So let's talk about normalization and its increasing degrees. Let's assume we will do this with an example because that's the better way, right? Let's assume that you have this table of freelancer, project, location, and skill relation. It is in 3NF form. So but still, as you can see yourself, there are some duplicates everywhere, right? You can see the duplicates, you can spot the duplicates directly, and these are the relations between the table, in the values of the table, right? Freelancer is can have multiple projects. One project can be done in multiple locations, and one freelancer can have many skills as well. So let's start off with BCNF. Now BCNF rule states that any attribute on which another attribute is functionally dependent is a should be a candidate key. Okay, now for example, we know that project is dependent on freelancer, location is dependent on project, and skill is dependent on this thing, because that's what we are trying to generalize over here, right? Show in our table, let's say. But obviously freelancer and skills are independent things. In that way you can know that these are linked together, as we have seen over here. They are also linked, and these are also linked. That means that violates the BCNF because the skill is not a candidate key. Alright, so we'll just come down and split the two tables between these two relations: freelancer and skill, freelancer, project, and location. As simple as that. There's not much idea of when you're talking about splitting, the relation will matter, and you can just split as per the relation. That's all you need to do. Okay, and that's it for BCNF actually, right? You have your BCNF format. This is a harder way or a strict way of doing the 3NF. Many people or many companies, many projects would have this, but still you won't normally see it in use in many places again still. Okay, let's talk about 4NF, which means to eliminate multi-value dependencies. Now after BCNF we had these two tables, right? But again you can see over here duplicates over here, right? How A, the freelancer A, is doing the project A and AD in two different locations. The same freelancer is doing WD in the same two different locations. That means we can see from here the relation, right? We have one freelancer, multiple projects. We have one freelancer and multiple locations. What do? We see two different relations. We simply change the relations. That's all, right? We have one freelancer, multiple locations, and one freelancer, multiple projects and locations over here. Now you can see over here, because we have duplicates, it's a multi-value dependency. Project is also dependent on here, location is also dependent on here. Then that because we are storing duplicates, more data is required. Because we have duplicates, more execution time of your queries going through your table is required to do, right? Going one by one on each row, trying to see if it matches your perfect thing. And that's it. If you identify something like this, duplicates like this, remove the multi-value dependency, and you make two relations of it. Now these will be joined together, right? Every time you do any kind of queries. Moving on to 3NF, sorry, 5NF actually, which will eliminate the join dependency. Now join is simply, as we know, is a Cartesian product of the keys that we define, right? If we are doing an inner join or outer or left join like that, for a natural it's different, right? We'll talk about the part of joins later on maybe, or maybe I'll make a video of it as well. All right, so projects, we can assume these three factors in the relations over here. This is coming from BCNF, right? this one is coming from BCNF and not 4NF. That is a very good point to notice over here. So 5NF is not a succession of 4NF, but a succession of BCNF, you can say, because here, as we have already separated these two relations out, there's no dependent joins, or there's no multiple joins happening, right? We already have the locations or the relations out, and there'll be one join between it. Now over here, because the idea is that with joins between the relation, we want to result into this table again. We should be able to result into this table. We have to make relations such that, so we have freelancer location, we have freelancer project, we have project and location. Now if I do a join between these three tables, I can get my original table back. And that's the idea behind 5NF, to eliminate join dependencies, right? You don't directly store the Cartesian product, but you make it different, so you can do the joins and make the Cartesian product properly and make your resultant set, let's say. Okay, nothing more than that. Now we go to 6NF. 6NF is a bit ruly about things. Okay, now we have to assume some things here. First of all, we are assuming the freelancers can add and remove skills. Obviously they can. Project can change locations, and projects can change, freelancers can change their available times. Okay, now the thing is, when a skill is added, you need to write down what time it was added, what date the skill was added. If you got a certification, let's say, you write down what date you got that certification, right? It's written on the certification literally. If the project location changes, let's say right now we are doing it in India, right, and the project is moving on, for the client is moving on to some other place, USA, Canada, or something like that, so they will obviously have a change date, right? It will not be like the project just shifted to India and the same row got updated. Then if that happened, let's say if we have a project and we have a location, let's say project P1 is working in India right now, okay, and suddenly it shifted, then we don't have it's India anymore, we just uh, let's say we have USA here, okay, then what would happen? There would not be any record of project being in India ever. That's why it has to be timed. USA with the date or time, right? The timestamp, and India till, let's say, the start and the end time over here. So you know from here to here what time is between. They can track the details as well. You can make reports of it. All those things are important, right? So each fact has to be timestamped. Each fact has to be timestamped. Every time something changes, it has to be timestamped, and a new row or something has to be created, or a new entry has to be done with different values, with the varying values, right? So in that way, let's say if by this assumption over here, by these assumptions, we have these different locations, or these different relations, right? Freelancer with skills and the acquiring date, right? Freelancer starting on this project, the start date of that work, freelancers working in a specific location, and the start date of that location. Now let's say this A freelancer is working in USA for and till some date, or started working here in this date, and 1 month after that we are saying okay, is going to work over here. The same with the project. Right now they're working with AD, then they'll work with AW. Right now they have Python only, but later on they have React as well. They added React to their own what do you say, their skill set, right? Now this idea is important of timestamping. Now let's talk about a little bit let me increase my brush size and remove certain things over here, or rather remove just a thing below here, so we can just kind of do some things. Now the idea behind this whole thing, I'm changing colors for no reason, but the idea behind this whole thing is that when you do 1NF plus 2NF plus 3NF, This thing you will see in every location, every db. Every db that is normalized will always have these three basic. If they need some what do you say, if they need some like specific very strict rules, then they will have this as well. Okay, then they will have like some niche or strictness, let's say strictness they will have over here. Then if they need some niche thing like time value, they want like time stamping everywhere, right? Or they want to remove the ability of joins, or they want to do more joins, let's say, right? Or they want to remove the multivalued parameters or dependencies, then they use these three. Otherwise there's no need of them. Now the idea over here, as I said in my previous videos, I talked about a graph which would go like this. Okay, so here you have normalization. Okay, and here you have the performance of the db, right? And it would be a very gentle bell curve. That's all. Let me draw that again. Be a very gentle bell curve. This would be the maximum, the peak performance, right? Which could be either 3NF or BCNF or anything for your database. The thing is, the idea is that as long as you keep increasing the normalization, right? Oh wait, I think I made these things wrong. Wait. Oh. So this is not normalization, this is performance, and this is normalization. Okay, so this is peak performance, right? And normalization goes to 1 2 3 4 5 6, like that. It will keep on going. The problem is, as you do separate the relations, keep on separating the relations, or keep adding more timestamps or more values here, you have more things to do in the database. You have more extra fields to work with, you have more joins to work with, right? Which might slow down your performance very distinctively, and you don't want that. So to identify the very need of what normalization you need to do is by finding out what you're using the database for. Is it for only for read or for write? Is it a transactional DB, which is for like mostly are like 3NF? If it is read only, then you don't need to do normalization. You can do time varying things. You can do 5NF dependent, removing some joins, making them a little bit organized at least. But that's a topic, I suppose, for another time. Right now you can just understand how different normalization work. Which one you need at this point is different. You might not need all of them ever. You might not work with these ever. You might not see them in your life ever. You might just work with these three. You might not even see this. But still, it's just a concept that you need to understand, that ever if ever that situation comes, you need to know what you can do, how you can perform, and how you can make the database better. Good luck, goodbye, and thank you for watching the video. If you have any questions or anything that you want to ask me, let me know.